Okay, so next topic is also we are going to discuss motion under gravity. In motion under gravity, we have studied that if a body is thrown vertically upward, so how much is the height? Sorry, how much is the time taken? Time taken is equal to u by g, and how much is the height? H is equal to u square by 2g. So one thing it is very clear that, listen, one thing it is very clear that, so here t is equal to u by g is time of ascent is equal to time of descent. That we have seen in the previous video also. And height covered in the upward direction will be equal to height covered in the downward direction. But the thing is, if we take, or if air resistance is to be taken, then the thing is different. Then time of ascent is actually less than time of descent. So that is the most important thing you just keep in your mind. Okay, so we are going to prove how it is possible like that. Okay, so first we will consider time of ascent. Time of ascent, so we will consider that. So what is the time of ascent? T is equal to u divided by g plus a. So why? Because the a value, that is in the case of upward motion, when the body is moving upward, so always you consider a value means the air resistance, where g is the gravitation and a is air resistance. So it's a retardation. Okay, but you always think that g is acting downwards and a is acting in the same direction. That is why they are adding up. Okay, so in this case, when the body moves upward, both of them will act together downwards. But this is not the case in the case of descent. So here also you can say h is equal to, how much will be h? U square divided by 2 into g plus a. Okay, but in the case of time of descent, so one thing you just keep in your mind, here the T2 value will be different. So here I would like to tell you how much is h is equal to u square divided by 2 into g plus a. Or I can say that in the case of descent, I can say that h is equal to half into g into t square. So here T2 square I would like to give, because since this is T1 and I would like to give it as T2. So h is equal to half gt2 square, because when the body is coming down, so here the initial velocity is 0, so how much will be the height covered? Half gt square. But here it is t2. But one thing you just keep in your mind, in both the cases the height traveled are equal. So I can say that half into g into t2 square is equal to u square divided by 2 into g plus a. Okay. But one small problem is there. What is that? Here it is not g. What is it? Here? Here it will be g minus a. What about here? It will be g minus a. Why? Because in the case of downward motion, or air always resists the motion. Okay, resists the motion in the g. So look at this, if it is coming downwards, so g will act in this direction, this air resistance will act in the opposite direction. Because you always know that. So when it is coming down, air is actually pushing up. Okay, it will push up. So that is why g minus a. So then from this equation I can say that, so the T2 value will be equal to, I will write here, so T2 value is equal to, look at this, so 2u divided by, okay, because 2 will get cancel each other. Okay, so u divided by root of g plus a into g minus a. Here what is the value? U divided by g plus a. So here time of descent will be u divided by root of g plus a into g minus a. So it is very clear that this T2 is actually greater than T1. Okay, you can check the value actually. This is g plus a into g minus a. G plus a is always greater than g minus a. Okay, so T2 is always greater than T1. So that is why we say time of ascent will be less than time of descent, unlike in the normal case. If there was no air resistance, both the values would be equal. Otherwise, time of ascent will be time of descent will be greater than time of ascent. Okay, I think you got it. And all right then. Okay, thank you.